Hello students, Professor Benavides here. Let's talk about chapter 4. Now this chapter 4 is about conditionals, but it covers a lot more. It covers built-in functions from the class math, or the math class. And we're also going to cover a bunch of string functions, which could have been like a separate chapter in itself. And why do we cover these other things? Because they're used to help us make decisions. And that's what conditionals are all about. For example, you'll say, if the sky is blue, then what? Then it's a good day. If not, then it's a bad day. So that's, you make a decision based upon a particular condition, and these conditions are in honor of George Boole, who is the was a mathematician, and they're referred to as Boolean conditions, Boolean variables, things of that nature. So let's drill down on this. So the first thing we see here is a flow chart. So George Boole was named after George Boole. And that means that the condition evaluates to true or false. In this particular little flow chart we see here, if the condition is true, then we'll do one thing. If the condition is false, then we'll do something else. This is referred to as a two-way branching construct. Okay. In Java versus Alice, how do we make these conditions true or false? By using relational operators. Relational and logical operators help us to build a condition that will either be true or false. Now, the operators that we use look a little bit different depending upon what language we're using. So when we're testing for equality in Java, we're going to be using the double equal sign. That's the test for equality for primitive data types. When you're testing for something that is not true, that would be exclamation point equal sign, right? Something less than or equal to, those two signs are one right after the other with no space in between them. So as she says right here, you can't type a space between the two equal signs, and you can't put in you can't reverse them as well, right? You can't put equal sign less than it, and it always has to be like a less than or equal to. So there's a variety of built-in Alice methods. For example, this one, get distance to. And I'll walk you through a little Alice demo at the tail end. I'm gonna go over all the concepts first, and then we'll play around with Alice, take it a step further, and then talk about some coding in Java as well. But in this particular case, we're going to be using the get distance to function to determine the distance between the monkey and the banana. And so the idea is that the monkey that's closest to it will say yippee. Okay, so there's your relational operator, and that's being used to create a Boolean condition. So we drag the if statement from the tiles down below inside of Alice and just drop it in the code window, and it puts in the else block on there whether you want it or not. So if you're just doing a simple if, then you wouldn't have anything inside of the else block. Methods in Java are a bunch of them as well. We start off with methods from the math class. So the math class is located in the java.lang package. So the java.lang package is a default package that is automatically imported into every program. Really important idea. Well, what kind of methods are we talking about, and how do we access them? The way we access them is we just type in math dot. That gives us access to the math class that contains all of these methods. For example, absolute, power, random, rounding, square root. And since they are methods, you can pass something to them and then they'll return a value, right? So they're like, in a sense, you could call them like functions. Here's an example. If I pass a 5.49 to a variable called number, which is a double, I can then go ahead and do an S out and say math.round and pass number. And that's your result right there. It rounds to 5. Okay. Another one that's used a whole bunch is the random method, right? And technically, this provides a number between 0 and 1, not including 1. That means 0.0 all the way to 0.999, etc. And you have to build this. I mean, you know, people are wondering, how in the world can I get a number like this to satisfy what I'm working on? Like if I'm saying I'm thinking of a number from 1 to 10, how would I do that? Or if I'm going to be dealing with the cards of a deck, I mean, you know, the 52 cards, how would I do that? So there's things, first of all, you generate your random number and then you just massage it, okay? Like say, for example, if you were to just multiply it times 52, that gives you the ceiling. The only problem with that is that you've got, you know, a 0, and there's no such thing as the 0 card, right? There's the card 1, right? And so what we do to fix that is we add 1, but now you're off. You know, you've scaled it, but now it's possible. I mean, you know, so you're off by 1, right? You got 52.99999, whatever. So what you do is then cast it to an int, and that'll give you the range from 1 to 52. So it takes a little forethought. If you wanted a number from 1 to 10, you would just use the same idea here, and instead of 52, you would have 10. Okay. Here's all those string methods. And you know, she shows you how to use this to make decisions. Like for example, you could go ahead and generate a random number. You know that it's from 1 to 0. So what you could do is every time you could say if that random number is between, you know, 0.0 to like what 0.5 or 0.4, then it's heads, and else it's tails. So you can use you use these methods to make decisions with the if statement or the switch statement. Those are the two statements that we're going to be studying that make this chapter called conditionals, right? You know, and they're called conditionals because things happen based upon a particular condition. And that condition will be Boolean. That is, it will be true or false. Okay, so let's go into the string methods, a whole bunch of them. So she walks you through this idea. She assigns a string to a string variable, which is really an object called S1, and then another string literal to S2. And then she walks you to using length to upper to lower, starts with, ends with, and trim. Let's go ahead and go through this. Length gives you the length, and it also counts the spaces, the blank spaces. To upper will convert that to upper. Of course, it really doesn't change the string because remember, this is an important fact, is that strings are immutable. So if you were to see the value of S1 again, it would all be lowercase. To lower does pretty much the same thing. And then starts with, ends with, return Boolean, true or false. So you can perform a test to see, you know, if a particular condition exists. Trim gets rid of spaces either, you know, on the left or to the right of, like say, for example, someone enters in a name into a text box. If they press the space bar and you're going to do a search for it, well, that character, the empty space character, is going to become part of what you're looking for. You don't want that. So you're going to want to trim situations like that when you get responses from the user. Now, if you're dealing with a string method, or if you're dealing with strings, you know, what we're talking about here is it's an object, right? So we're going to be using object-oriented programming methodology here. To test to see if two strings are the same, we would use the equals method. You would not want to use the double equal sign because that would test to see if those two objects are the same, not to see if the values in those objects are the same. You know, so most of the time you're going to want to use the dot equals to method. You can also ignore case. You know, in some cases, you know, if you're looking for something and if you're looking for it if you type it in lowercase but it's in uppercase and it does a character by character match based upon the ASCII table, you're going to want to go ahead and make sure there may be situations where you want to go ahead and not only trim, but also ignore the case. Then you can go ahead, and here's another one, contains, to see if there's a particular character or word within a string, which would then, the return would either be true or false. So here we see a comparison between objects and primitive data types. Let's take a quick look at the primitives since they're a little bit, they're not as wordy. So I assign 1 to A, 1 to B, and then I perform a test. Is A equal to B? I assign the result of that to result, and then print out result. Okay. And the answer is true, right? Because 1 and 1 are equal. Again, remember, if you're dealing with strings, the only way that you would want to use the double equal sign here is if you're wanting to compare string literals. Okay. But when you're actually comparing an object, which is string message, which is really an object, it's just a shorthand way of saying, string message 1 gets new string, and in parentheses feeding it hello. Let's stay with the primitives. On the right-hand side, we've got capital N going into a char of A, and capital Y going into B. Then we perform a test, and here we plainly see that the answer is false because, actually what's being compared here is that it gets compared to the ASCII table. Each character is represented by a character in the ASCII table, and that's where the comparison is actually made. When we're dealing with strings, we're going to have to use string methods to make comparisons and perform pretty much any other kinds of string manipulation. So we have the equals method to see if two strings are the same. Of course, they are false because the first character ends with an H. And then we have an example of how we're creating the decimal formatter. Okay. And let's see here, we have format 1, right? And format 2. And it's exactly the same format. And then we perform a test on this, and we're comparing objects. So they are the same. Okay. Then that brings us to string comparison, some examples of string comparison. I assign hello with a capital H to message 1, hello in lowercase to message 2, and I use the equals ignore case to go ahead and perform a test. And the result is true because equals ignore case will ignore the fact that 1 is capitalized. Here again, we see another example. I assign hello with a space at the end and a capital. And look at this, I trim both of them. Both of these, message 1 and message 2 are trimmed. And then I go ahead and assign the result to a Boolean. Now, and you're saying, well, why aren't they, I'm equals ignores case, and of course there's a space on there. The spaces have a value, believe it or not. Yes. So the idea here also, no, excuse me, that was a trick question here. What? If you trim them, nothing got done. And let me reverse this here. If you say message 1.trim and message 2.trim, remember strings are immutable. So nothing got the original objects didn't get changed. So when I do this comparison here, I'm doing a comparison on the original on here. So when we come over here to this one here, equals ignores case, we get a true. So let's go ahead and look at this again, how different it was. I have message 1.trim, the return of that is being assigned to message 1. Then the return of message 2.trim is being assigned to message 2. So both of those objects have been updated. So when I say equals ignores case, they've been trimmed. So if they've been trimmed, that space is not messing up stuff. So if I say equals ignores case, then the return is true. Then they also talk about you could also just use the trim function in the actual comparison, but this example is a bit wordy on here. So conditional statements, the first example is a standalone if, a single line if. It tests one condition and it provides no alternative. see, here's the syntax for it. Here we have an if-else. So this is the two-way branching construct. So if something is true, something happens, else something else happens. And then we have the else-if structure, which are really great for testing a long ladder, excuse me, a long table for, of contiguous ranges that need to be tested. And when you're using the else if, you have the option of using an else at the end, where if none of the else ifs catch, then you use the else as a form of, in a sense, validation. Like you could say, enter in numbers 1 to 4, and if they enter in 5, well, that's the else, and then you can go ahead and catch that and give them appropriate feedback. Here's some examples. Here's a single line if, simple if. I assign 1 to x, and I go ahead and say, hey, is x less than 0 on here? And guess what? Nothing happens, right? Because, you're saying if 1 is less than 0, so this S out does not fire. Right? Here in this other example here, I have an else situation. And in this case, I say that x is positive. That's what prints out. Why does this print out? Let's go through this slowly. 1 is assigned to x, and then I perform a test. Is 1 less than 0? No, so this one does not fire. The body of the if does not fire. The body of the else, remember, a body is code defined within curly brackets. So what prints out is that x is positive. Here we see an example of an else if and a trailing else on here, and the logic expands where the possibilities are x is negative, x is 0, and x is negative, 0, or positive, depending upon the number on here, and it makes sense. Here's how you use the random method to go ahead and simulate a coin tossing. The random method is, they say it's really pseudo-random, but it's pretty good for me, to simulate, randomness. So what happens is that we know that the number generates between 0 and 0.9999999. It goes on forever, it seems like, right? But so if R is greater than or equal to 0.5, then we say it's heads. Otherwise, it's tails. So, how you use these methods, again, remember, we're covering all these methods because they can be used to help us make decisions. And here's a good example of how I'm using the random method of the math class to generate a random number that I'm going to be using in an if statement to help me make a decision. Right? In this case, I'm printing out heads if it's greater than or equal to 0.5, else I'm printing out tails. The logical operators include, and, inclusive or, exclusive or, and not. Thing to remember here, these are some, if you've never seen these symbols before, the exclamation point is the symbol for not, and it's used in a lot of programming languages. Another one that may be different for you is this. She calls it the inclusive or, but this is called by many it's called a vertical line, right? Or the pipe symbol. Those are the more classic programming terms. And she says that you can acquire it by holding down the control key and hitting the key above the enter key. Well, that's just on some keyboards and really not on any. To get to it on my keyboard, let's put it this way: you hold down the shift key and press the key that has it above whatever it is. It typically is above the enter key. So you hold down the shift key to get to the vertical bar. It's called the vertical bar or pipe symbol. Okay. Then she talks about gives you examples of the logical operators. Basically, both sides of you have one condition on one side that's being tested, and you have another side that's being tested as well. You can negate one side if you want with the not. This is not with the exclamation point. Now, there's also something called short-circuiting logical operators, and what happens here is that you end up with a performance increment because one side is not tested because it doesn't make any sense to test the other side. So, so the first condition will be tested, and if it's false, then the computer will not bother to test the second condition because the logic already knows that, hey, if I got to have both sides be true, why even bother? So you end up with a performance increment. That's why it's called short circuiting. Then you have the double bar, double vertical bar, double piping symbol, referred to as short circuiting OR. If either condition is true on both sides of the double bar, then the result is true. Okay, so it doesn't bother to test the other side of it already. So the first condition will be tested, and if it's true, the computer will not bother to test the other. So whether you use a single ampersand for and or a single one, that's pretty much up to you. You just got to know how they work. When you use the single one, both sides are tested. When you use the double, you end up with a performance enhancement. You're not going to be able to tell the difference in this unless you're like probably dealing with thousands of lines of code that you're looping through. Okay. So here's an example of how these logical operators are used in code. Here we're performing a test to see if x is less than y and whether or not x is less than z. So both of these will result in a true or false situation. Okay. So for an and to be true, remember these are called logical operators. Both sides, both of those conditions need to be true. Okay. So the hierarchy of operators, remember parenthesis rules, right? It can modify anything. Then we have incrementing and decrementing, and then we have multiplication, division, and the modulus, and then plus and minus, and it just goes down the list for the relational operators, the logical operators, and the shorthand abbreviated operators. Then that brings us to the switch statement. Switch statement, probably not as popular as the else if. Some people do like it, and she says that it can evaluate, look what she says, it can evaluate byte, char, short, int, or string. Where's double? You see double on there? Because it doesn't work with doubles. And so there's a couple of I gotcha. All of these structures have I gotchas. One of the biggest I gotchas on this one here is if you forget the break statement on here, you can mess up the logic pretty good. Let me show you what it looks like here first. So you can pretty much do the same thing with an if as you can, well, not exactly the same thing, but almost the same thing. How's that? You can do almost the same thing with the switch as you can with an else if structure. So let's look at what's the same. One here, or what's different. Notice the switch has these break statements, and if you forget one of these, it goes down and reads the next one, and your printout will look weird. We also have a default clause in the switch statement, which is the equivalent of the else, the dangling else, right? Then we have another comparison on here where you could sort of, even though you can't do doubles, you could sort of simulate a range by using, like, you can say like case 1, comma, case 2, comma, case 3, comma. So that gets kind of wordy, where I could have specified the range a little bit easier with relational operators in an if. So that brings us to the hands-on exercises, and there's lots of them. And I want to go ahead and walk you through a few of them. There's the shark moves to the closest fish. Remembering, I really think that you should go through the exercises in your book as each step tells you you should go ahead and go through them, and then walk through it. But what I'm going to do is right now is I'm inviting you to, once you have finished your exercise, why don't you just go and ad-lib it? See if you can recreate it. See if you can spice it up and make it different, right? You'll probably learn more through this intrinsic activity. But remember, only turn in what's asked for. Let's see if we can play around with this a little bit. I'm going to go ahead and start Alice. And I'm going to try and recreate this shark thing. It may not be exactly the same as in the book. So we start with the seafloor. And then we'll add the characters, I mean the fish, right? And then do a save. Or you could save early right away, it doesn't matter. So we'll come over here and she says put a shark and 2 fish on there. It doesn't matter, she says, which fish you use, but guess what? If you don't use the ones that she had in the picture, then when you get to the code that you're typing in, then you're going to have errors, right? Because you can't be typing in clownfish unless you added a clownfish, right? So I would go ahead and just add them in the way first thing I'm going to do is I'm going to put in a shark. So there's my shark. If I just double click on it, it adds it. I'm going to accept the name shark. And it puts it on here. And he looks really big. She doesn't tell you to do this. But I'm going to go ahead and select my shark. And I'm going to click on the resize button. And I'm going to make this shark smaller. I just think he's just way too big, you know? Way too big. Yeah, so if I make the shark smaller, well, maybe a little bit bigger. You know, I'm going to have to make the fish smaller too. I didn't drill down on the galleries because it just takes too long. I already know what these are called since I've been through this exercise before. The clownfish. Double click on this guy. If I double click on the guy, you know what? It's going to go right in the middle, and you're going to get confused because you're not going to be able to see him. You know, you're going to say, oh, it didn't happen. So you're going to double click on it again. So I'm just going to drag this little guy in here, right? And then I'm going to accept the object name. Since I'm already on resize, I'm going to go ahead and make this guy just a little bit smaller. Oh, I made him too small, right? Just a little bit smaller. And I want to he looks like he's a little bit in the water. So, you know, for my purposes here, I'm going to go to move. Yeah, I'm just going to move him up just a tad bit. I probably shouldn't have done that, but I did it anyway. Or maybe I did. Maybe I didn't. And then they will add the blue tank. And put this guy over here, right? Accept the default name. And let's make this one smaller too. Oh, I was on the move where I wanted to go and resize. I'm doing undo. And I'm going to go to resize on the buttons here. And make this fish smaller, right? And I don't think I need to make a move. I mean, you could go really particular because if I remember on the thing, he was kind of like facing one side. So I mean, if you wanted to, you could go to default and then just move this little donut so that he's looking a little bit this way. Because I think that was the way he was in the thing. But she doesn't tell you that. So I mean, you're pretty much free to go ahead and develop your little scene. You know, like this. And then we're going to go into edit code. And then she says, select the shark. And I'm just going off of memory here. And what we want to do here is get the mouth from this drop-down list here. And I'm going to go ahead and go to shark. And we're going to say get mouth, right? And we want to do that so that when I can get to the methods that I need to get to, I need to get the turn method on here and drag this and drop it right in here. And then I'm going to go ahead and go forward 0.25. And you know, I should have added the comments in there. Who doesn't work backwards? So let's get the comments in here and pop it right in there. And it's, what is it? It's name, the date, and description. That's good enough, right? So after I add this little guy in here, if you want, you can just run it and test it. See how he opens his mouth? If you follow the directions of the book, I don't think you run as often as I do. I like to run a line of code and test it. You know, the other thing that I did that she doesn't do, I won't bounce around too much here, is back to scene setup on here is you may fool yourself into thinking that one fish is closer to the other guy, to the shark. So if you can go up here and go to layout scene view, you can see which one is clearly closer. See, my little blue fish is closer to the shark. So because basically the shark is going to go and eat the one that's closest to him, right? So I'm going to go back to camera view, because a lot of times you can move them and you're not really too sure about which one is closer, right? And you always want to verify this. So now what we're going to do is we're going to get we're going to use the get distance to method. So I have to go back to the shark, choose the shark, and then I'm going to go ahead, and if it's a function, that would be in the green area here, I would get the get distance to, and I'm going to go ahead and drag that and put it right here. And then I'm going to go ahead and, did I get that? I didn't do that, did I? Oh, I haven't finished the line yet. Get distance to who? In this case, I want to get distance to the clownfish. So I click on clownfish, right? There we go. Okay. So, no, I think I messed that one up. So I'm going to go on undo. And then let's go ahead and come back over here to where I was. Get distance to what I wanted to do. Oh, I want to get the if statement first, right? I'm going from, so we'll drag in the if. This is a tile. Just drag it in, except true. And then what we're going to do now is we're going to drag that get distance to inside that true statement. Okay, fine. So here's the get distance to. We're going to drag that, and we're going to drop it right in front of this true. Right? Oh, no. We're not going to drag it. We're going to go ahead and use the drop down. So we're going to use the decimal, and we're going to use the first one on here. And I'm just going to put placeholders of 0 and 0. Okay? So we're saying if 0 is equal to 0. Those are just placeholders. Then finally, I've been trying to drag this little get distance to over there, right? Haven't I? So I get this get distance to. Now I can drop it inside the first one. And I want to get distance to the clownfish. Right. Now I'm going to go ahead and get the other one and drag that in here. Notice how I'm still up. This is the shark, so this would be to the blue tank. All right, so it's got to make sense here. So if the shark gets distance to the clownfish is less than the distance to the other one, then what am I going to do? Then I'm going to move to the clownfish. Okay, so the move to, that's an action. The words tell you where to go, whether you want to go with a procedure or a function. Whenever you say get, you go to function. Whenever something sounds like just action oriented, then you will use a procedure. So I'm going to get the move statement and drop it right in here. And I'm going to go ahead and move to who? Let's see here. Move to, hold on, let me click away and try that again. You want the move to, that's this one right here. Move to target. It didn't give me a target, did it? Drop, and then here we can specify move to the clownfish. All right. Then the else thing, I'm going to cheat a little bit. I'm going to hold down my control key, and I'm just going to drag it and drop it over here. And then I'm going to click a little down arrow and choose the other one. Yeah, I'm a cheater, right? The next thing on here is to get the mouth and simulate, if he opened the mouth, then we're going to go ahead and simulate it closing. So what I could do is just go ahead and do that. If I wanted to, I could just cheat again and just get this over here, drag it, drop it over here. And then in terms of forward, I would go ahead and change that to backwards, right? Let's go ahead and run it and see if we need to make some modifications. And did I forget to save? No, I think I did. So I'm going to go ahead and go to File, Save. I'm going to go to the desktop, and I'm just going to call this Shark, because this is just our free form, right? All right, so let's go ahead and run this. So the shark opens the mouth, gets the other fish, and eats it. You got it? All right, so what you also may want to do is, let's just verify everything on here. Yeah, he looks okay. I probably would want to move him just a little bit higher so I could see all his fins. Somehow or another, the fins look like they were down in the water. So let's run it again. Yeah, that's a little bit, well, I thought that was a little bit better. Okay, so now for the play. What else, what else do we want to do? That's only, I mean, I think this is what you're going to be turning in, But if you want to just play around with this, you know, you could go ahead and say, well, I already had him close his mouth. Why don't I go ahead and do a forward on here? Oh, did I do a control thingy? No, I didn't hold on the control thing. So let's do an undo. I'm going to hold down the control key and get this and drag it over here and then release. So now it's closing. Let's just have it, or opening, excuse me, close again. And then now what? Let's just go ahead and drag this in here and go to custom and say what? Oh, not instead of a say, let's do a think. Because it looks, it's got more like, it has little bubbles coming in here. So then we'll say what? Burp. Right? If you get more creative with this, you can have them spit out a little skeleton or whatever. Let's see if that works. Run. Shark goes to the little fish, eats it. See how he's chomping down on it? Burp, right? So you know you're getting good if you can figure out a way to get like a little skeleton fish to pop out of his mouth after he's finished. That would be cool, right? Then you're not finished now. You want to test your code. Remember, you want to see that if move the little fish closer, and then the other one just move that a little bit further away. If you can't tell that they're the distance here, go into the layout thingy and see, yeah, the clownfish is definitely closer, because I've had some students think that it's closer and it's not. So let's go ahead and click run. Yep. So I know the mouth goes down a little bit below. What you could do is just raise the shark a little bit higher on that if you wanted to get more of an effect on there. Okay, so that's how you can fool around a little bit with Alice and experiment and learn intrinsically from it. I'm going to go ahead and save. The things to remember here is that every time I drag something onto the screen, I'm using these templates. These templates are classes, and I'm dragging them on the screen to create an object. And then when I go over here to the code, what I'm doing is I'm using the pre-built methods on here to help us make decisions. And I use them inside of, in this particular case, an if tile. I dragged in an if tile from down below. I also dragged in the comments. And then I went ahead and filled in the blank. I just banged it out and it ended up getting there, right? So let's go ahead and our last save and close. Okay, let's remember that gives me shark, and then it provides us, you know, with a folder that's a backup folder. This confuses a lot of students, so please try to remember we're not going to be working with .bak folders at all. All right, so let me go ahead and open up NetBeans up, and let's talk a little bit about the if and the switch statement a little bit more. And I have a couple little demos that are already prepared. What you want to do is, if you have projects that come up, just close them so you won't get confused. I mean, if you can handle that, fine. You can just leave them on there. But I always tell people just close them. Just right mouse click on the project and close. So we're going to go to open, and I'm going to go to the desktop. And on the desktop, I've got one project called password, and another one called personnel database. I know it's called human resources nowadays, right? Now let's just look at the logic, see what's going on. I import scanner. I set a password to a particular password, and then I prompt for the password. I go ahead and get it, put it in password response, and then I perform my test using two-way branching construct. So, and notice how I use the equal sign, excuse me, the equals method. So I say password key dot equals, and I pass it as an argument password response. So if they're equal, then I'm just going to simulate that if the password is equal, that they will be going to the program menu, right? Else, you just simply say password is incorrect. I did want to take a note here as to showing you why you can't use the or the results that you would get. See, some students would say, well, why can't I just say, you know, password key, you know, equals if password key equals password response. And of course, the answer to that is that you can't, unless you really wanted, unless you were wanting to compare the two objects being the same, so that you're not really comparing for the values inside the object. So what we're talking about, that line there on line 20 will end up being false, even though I'm going to assume that I'm going to type in the password correctly. Then but if you were to do a string literal, then yes, it's be okay to go ahead and use the primitive test for equality here, or the double equal sign here, or equal sign. It does give you a little hint on how to fix these things. If you click on the little down arrow, look at it, it says, hey, use the equals method. Come on, right? So in this case, you can see that the editor's helping me out. So let's just go ahead and run this. It's just a simple if. I wanted to talk about, maybe it wasn't really quite apparent why would we use the equals method versus the equal sign. So let me go ahead and run this. And I'm going to try and put in the password correct. Down in here, I'm going to go ahead and type in Bob, exclamation point, press enter. And it says, password incorrect, false true. What happened here? Did I type it in wrong? Oh, I just typed in Bob. Of course it's incorrect, right? And I forgot the numbers, right? So let's go ahead and try that. Let's try this again, and maybe I can type it in right. So that's capital B-O-B, 100, and then the exclamation point. So I got to the program menu, right? Right. So if I got to the program menu, that means that line 15 fired, that this test here was true. This Boolean condition was true, right? Then I go ahead and perform a test to see if these two are equal this way. And of course, that's always going to be true. I mean, false, excuse me. It's always going to be false. And of course, this will always be true because if you're performing a test on string literals, then it is comparing every character. All right, so let me put in the wrong one. So if I put in a password, it's incorrect, right? So in that particular case, the else fired, okay? Okay, so let me go ahead and get the other example here. Open project. Now let's try the personnel database. Probably should have called it human resources, but back in the good old days it was called personnel, right? So it's another scanner application, and I simulate a menu here, human resources database, and I just say, hey, enter in 1 to add an employee, 2 to remove employee, 3 to edit employee, 4 for employee reports, and then I just prompt them for the number. Based upon that number, I know we haven't covered methods yet, but it's around the corner here. I'm going to call a method called useIf, and it's going to come over here, and everything inside of here is going to execute. Then we're going to go ahead and comment that out and use this other method. It helps me organize or distinguish between an if statement, and then we're going to compare that with the switch statement. So for right now, inside the switch, as you can see here, I test to see if X, in other words, that's what's coming in, that's the parameter variable in this method, which was passed in through number. So I get number from the user, and I pass number to useIf. That number then goes into X, and I test it inside these statements here. So in this particular case, I say, hey, is X equal to 1? If so, add employee. Else, if it's not, then just go down the ladder here. I do have a catch for validity here on the else, which I say, hey, please enter numbers in 1 to 4. And I'm going to go ahead and talk about when you should use curly brackets and when you should not. Well, let me just tell you right now. The correct syntax is to use curly brackets within the body. And it's because if you don't, you might end up having a logic error. Now, if you're only using one line in the body, like I'm using here, there isn't a need for the curly brackets. Okay, so it simplifies the look of the code. But if you enter in another line, you might get confused. Like when? Let's say if you have an if embedded in an if, then your logic is going to get messed up. And then I'll show you another simpler way that you can get mixed up. in just a minute. But let's just go through this. Let me just show you how it works. So I'm running this, and let me expand my view here. So it says human resources database, enter in a number. I'm going to go ahead and enter in 4. So it's that let me into the employee reports menu. Let me run it again because we don't have a loop. That's our next chapter. Can you imagine we can redo this this app as a loop so that the program doesn't end and it'll just loop through and give me the menu again, which is cooking with gas, right? And that's the way to do it. So I'm going to enter in a 6. There's no 6 on there, right? So then it says please enter numbers 1 through 4. So it fired correctly. Instead of letting me into a particular database. And you're going to, anytime you make things like this, anytime you make an else if ladder, you want to test every single one out. You want to make sure that the one gets is firing correctly. Later on, when you start programming here, you're going to start learning that each one of these could end up calling another method that will have all the code related to adding an employee database, or all the code related to removing an employee, etc. This is just like a plug-in for me to go ahead and add more code, later on, right? So let's talk about this little thing that I have commented out right here. What happens if, let's say that I wanted to go ahead and say, please try again. Let me put it in the right place, right? And I wanted that to happen as part of, like if I type in a 7, right? I wanted to say, please try again. Let me go ahead and try it with the 7, and then we'll try it without the 7 and see, maybe I'm spooking myself out, which is happens sometimes. So we'll put in a 7, and then and it should say, please try again, right? Okay, well, that's cool. But let's try one of the other ones now. Enter in a 1 or a 2. Why does it say please try again now? I should be into the employee data, into the employee remove employee menu. Why am I getting this please try again? I mean, isn't it part of this? I indented it right here. I only want, so the idea here is I only want this line of code to fire on the else. Why am I getting it? Yes, and I will get it for all the other ones as well. Let me try a 1. Please try again. No, it should just take me to the employee menu, to the add employee menu. That's because I didn't use the curly. If you have more than one line of code, if you're going to have more than one line of code, you're going to have to enclose that in curly brackets. Otherwise, really, the way this is being read, guys, this is being read as just another line of code. Another line of code. So that's why it's firing regardless of what else that I'm going into. So if I want this to fire uniquely in that situation, then I would put in my curly brackets. So I put in the open curly brackets, it put in my close. I'm going to go ahead and do a control X and paste it right in here. And I'm going to go ahead and run it again. And let's run it with and without. Hopefully it'll work. If not, I'm going to need to go back and study my logic. So let's put in a number 1, see what happens. It says add employee. That's what I want. Okay, so let's type in a number out of range. Well, that would be a good response too for that, something like that. Let's type in an 8. Please try again. All right. So it's as you can see here, there's a reason for these. Some people say, you know what, for safety purposes, just go ahead and put in the curly brackets so that in case you add another line of code later on, in case you add another line later on, it'll be ready for expansion purposes, right? It's ready for you to go ahead and add more code. So that's pretty much up to you as to, I like to not use them sometimes because for instructional purposes, the code gets really long and it's kind of hard to see, it's kind of hard to see on the screen, So let's go ahead and look at the next example. I'm going to comment this out, and then I'm going to go ahead and uncomment this one, which is it's going to call, just think of this as a container code for right now. So it's going to call use switch, and it's going to pass the number, and then it comes in here, and that number goes into Y. And I use different numbers here for debugging purposes. and here's the switch statement. So it gets the Y, notice it's an int. What happens if I change it to a double? Let's see what happens. Why do I get an error here? It's no error up here. It's an error right here. And let's see what is. Sometimes it's helpful. Remember we got lucky last time? It says it's incompatible. That means that I can't feed it a double. I have to take this back to an int. So that really limits. I mean, I think that's a big limitation for the switch, in my opinion. And you're going to see other limitations like ranges and stuff like that. You can simulate the ranges, but it's still not, not the same, not as powerful, in my respect. So here's that same idea. So I bring in number, and then I say case 1, but then I got to add this break statement. This is the same logic as before. I had my if, else if, else if, else if, and then default. The default is the equivalent of the else, right? But now here's another hidden danger. Well, let me run it for you so you can just see how it works, right? That it's equivalent before I start breaking things, right? By the way, that's another way to learn things. The way I promote, and do it the way they tell you to do it in the book. Exactly. Learn your foundation principles. After you can do it the way you're taught, then you branch out and explore and break. We have breaking things is exploring, right? So let's go ahead and just do the number 1 and see if that works. Yeah, add employees. So let's go ahead and run this again. And then I'm going to type in a 9. And then it says, please enter numbers 1 through 4. So it's working just fine. So now what I want to do is I want to get rid of this break statement. Getting rid of it, I'm just going to put a comment in front of it. And let's run it again. And let's choose number 1, see what happens. So I put in a number 1 on here and press enter. Now it says add employee, fine. But then look, and then it goes and says remove employee. So in other words, what happened here is it went down to the next case statement and printed out remove employee. That's not what I want. And it's easy to forget the break statements is what I'm trying to say, right? Easy to forget the break statements. I'm fixing it right there, proving it that we're fixing it, putting in a 1 again, and it should not bleed into the next case statement. Okay, so those are my little demos for for today. I want to thank you for being with me and hearing my rendition of this chapter. Remember, at the end of every chapter, you have the hands-on exercises. There's no way possible that you could probably get all of them assigned to you, but as many as you can consume. This repetition of ideas will ingrain the code into your system. All right. After you go ahead and read a chapter, or as far as you can go on it, remember to go and find that summary. So a lot of people say, well, it's way out there right after the hands-on exercises, but keep on going. And the summary is an excellent way of putting everything together. We talked about, yes, we talked about conditionals, the if and the case statement, but we also talked about a lot of other things like relational operators and logical operators, and they're used to help us make conditions, and these conditions are Boolean in nature, right? We saw that the switch statement can handle a byte, a char, a short, an int, and a string. She probably could have said that you can't put in a double in there, right? When you're creating your conditions, you have to remember the laws of operator precedence, but remember parenthesis has a tendency of making things easier to understand. So I would definitely ask you to go ahead and do so. Other than that, Professor Benavides, peace.